Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Hes 2001M. This is what is called a plug-in bridge rectifier. And a bridge rectifier, in summary, converts AC voltage to DC voltage. The term bridge refers to the way in which it goes about doing that. You can search online to find a drawing that represents the process that is happening. And without me refreshing my memory of what happens when AC is rectified to DC, the current is clipped in such a way that the resultant is compatible operating as DC voltage. It's not true DC voltage, but it allows us to power DC components with AC voltage by using a rectifier. This rectifier from Hes can be field selectable for 12 or 24 volt DC coming out of it. So this end is the input coming from your AC voltage. This is going to plug into your Hes strike. My client's using a 1006, and I know that they're powering it with AC voltage. Now, and this strike needs to operate as DC, primarily because they don't want a buzzing sound in a fail-safe electric strike application or an electromagnetic lock. Here's what I mean. AC, you'll know that it's AC voltage when you hear a strike buzz. You go up to the gate, and via the intercom, the tenant who you are visiting buzzes you in. That's AC voltage. Well, that works when you have a fail-secure deadbolt, meaning when there's no power, the electric strike is in a locked condition. The keeper is rigid, the lock doesn't work, but when they power it, it buzzes, the keeper opens, allowing the lock to come open. Now, what if you had a piece of hardware that was continuously powered? Okay? Like a fail-safe strike, that meaning when the power when the circuit was opened and the power was cut, it would then be unlocked. That would be buzzing continuously. An electromagnetic lock is a prime example because there is no such thing as fail-secure electromagnetic locks, meaning the big heavy magnets that you can see at the top of the door, 600 pounds, 1,200 pounds, 1,500 pounds of holding force, those must be powered to be locked. So therefore, if they were powered with AC voltage, they would buzz constantly, and they would only not buzz when the door was open. So you definitely don't want that. I've never seen that sort of application. But this is what it looks like. It's going to come with simple installations. It's literally plug and play, and you just have to plug it in based on how it's being shown here. You can't get it wrong. If you're going to use this, you can't get it wrong because you need the female side on one side for the strike to plug into. You then just have to elect what voltage that you are operating the strike at. If you're not sure, you'll have to put a voltmeter on your power coming in, but your power supply is going to, it will tell you what voltage is coming out of the power supply. But if it doesn't, you have to determine that with a voltmeter. You don't want to plug it in and say, oh, okay, let's try the other voltage. Yeah, you don't want to do that one. Now, below this video are a couple of links, and let's switch to the screen view where we can take a look at both of those. Now, here is the item that we are looking at. Plug-in bridge rectifier. Change current with ease using the bridge rectifier. Converts AC to unfiltered DC. It's not a pure DC sort of current that you're getting, but it is compatible with our componentry. Rated at 35 volts for up to 1 amp. So be mindful of what you are powering through this, and that's always you will always see a rating of a piece of electrical equipment specified or indicated. What I mean by that is whatever you're connecting this to can't exceed 1 amp, including its inrush. So I just recently did a job for a client where we were doing an SDC SDC electric deadbolt. Well, that was only requiring about 400 milliamps or 0.4 amp, but it had an inrush requirement of 2.5 amps. And I think people would probably tell you, yeah, it's going to work. It's not correct. It probably won't work long term, but that micro burst in milliseconds of the inrush, it's going to eventually fatigue and cause the equipment to fail. But the bottom line is, you couldn't use this bridge rectifier with that scenario because it's not rated for that inrush, even though the fact that it's just a few microseconds, a few microseconds, okay? Resettable fuse. Now, it's not recommended for the for the 1006 electric strike. Now, that's very interesting. Let's dive in and find out why that's the case. Now, I realize that earlier I said that we're using this with a 1006, where I'm actually using it with a 5700 series strike. And to discover what is the correct unit to use, we're going to click on the catalog page. And on page 2 here, you're going to have some simple accessories. For instance, a wire-in style bridge rectifier that you're going to hardwire it, and then a plug-in style. Neither of these are recommended for the 1006. They have Electrolinks connectors, which is a quick connector system under the ASA Abloy umbrella. You'll find other sister companies to Hes using Electrolinks, such as Yale and McKinney, etc. Now here's what you use for the 1006. The Smart Pack 3. Addition of Smart Pack to any electric strike extends the 5-year no-fault warranty to a 10-year warranty. Inline power controller able to receive input voltages from 12 to 32 AC or DC, has a built-in bridge rectifier, reduces the initial voltage by 25% to extend the life of the electric strike, has that resettable fuse, and is intended for use with the 1006. Okay, so this has been engineered to be used safely with the 1006. You have an annunciator here as well. Should you want to have DC power, you have DC power because let's say that you're locked into a DC source of power, some other equipment, but you still want to have an audible indication that the strike is then in its state to be used, or in the opposite condition, like it's unlocked. You can use a plug-in buzzer or an annunciator or a horn or whatever. It's going to be a buzzer. Plug-in pigtail connectors. You might need connectors. If you're using Electrolinks, you might need some sort of connectors. You might if you're going to get a Hes electric strike and you're going to use a Smart Pack, you're either going to buy a connector or you're going to cut these wires and then hardwire it. So you're better off just using the factory original connectors and then hardwire one end. It does come back the same way, but I would want to preserve the integrity of the Smart Pack itself and not do my terminating by modifying the original equipment. On the final page, they list some crossover charts. If you're looking at a 1006 km strike, I think we're using that with a I don't recall, it might be a Yale mortise lock. You've got some crossover part numbers. A Folger Atom is going to be a 742.75. Von Duprin RCI. Trine does not have one in that column. Oh, they do. It's the 4100. SDC has some strikes as well. There's nothing that is compatible or that cross-references cleanly to that. Then there is the user's guide, and let's take a look at that next. Now back to the item that we are reviewing here. Catalog page is clear. The user's guide is that small piece of paper that's folded up within the unit itself. And what's interesting is they do show a 1006 here. Pardon me, a 2001 with their 1006. So given the date of this document, the document that is included is the identical document as listed here. So we're going to follow the manufacturer's guidelines and use their Smart Pack, is what they're saying, to use in that regard for this strike. Okay, so if you're dealing with AC voltage and DC componentry, you'll certainly need a rectifier, and every manufacturer of Electrified Hardware makes one, and if they don't, that's not a problem. You can use a Hes. You can use their sister companies, Adams Wright. Securitron, I'm sure, makes one, etc. They all will do the same function. You do, of course, again, need to be quite mindful of your electrical profile. You know, what is it rated for, and be sure to stay well within those limits. And speaking of limits, when you are designing a system anew, you want to have a 50% margin. So what that means is if you are dealing with a 1 amp power supply, you would really not want to exceed about 650 milliamps in terms of what you are running, not including any sort of inrush sort of requirements. So the point of what I'm driving at is 650 times 1.5 for your engineering, you know, allowance. You're at 975 milliamps. So, you know, about 650 milliamps would be the max for a 1 amp power supply. And you know, if you find that you exceed you know, a 1 amp power supply with your 50% margin, go to an amp and a half, or go to a 2 amp, whatever is available for you. Power supplies are not expensive at all comparatively as to how they used to be, most certainly. So you should not end up seeing a substantial price difference there. Now, there's a link here below this video to the manufacturer's page where you can pull up not only all of the Hes products that we sell, HES, but a link to the manufacturer's website, as well as a link to the product catalog and other archival documents, encyclopedic documents, we will leave here on this page as well. Let's finish up this video on camera. Now, in conclusion, the name Hes, or HES, they've been I first became aware of them, I believe, in the 1990s. And the selling point of the Hes strike was that really large keeper on the 1006. And that keeper was large by design because the system that they put into effect was the modular faceplate system. So you would use the same strike body, and then what you would do would be use different combinations of faceplates. So if you're doing cylindrical locks, great. If you were doing mortise locks, great. Different variations of that material. And the list of their faceplates is quite long and detailed to be able to allow you to use a single electric strike to simplify inventory, to simplify your preparations in the frame, etc. And to more smoothly be able to facilitate the delivery of an electric strike to market. You know, you've got a strike, just tell me the lock, I'm going to swap out the faceplate. Faceplate design and finish, obviously. So that's how the 1006 and Hes was sold to me originally. There's lots of options when it comes to electric strikes. The good thing about Hes is that it is grouped under the ASA Abloy umbrella of companies that are all related to what HES does. Fulgeratum, obviously, electric strikes. But when it comes to electrified hardware, you'll have Securitron. You're going to have Yale, Corbin, and Russwin. You're going to have Sargent. You're going to have Medico, Rockwood, McKinney, Adams Wright, and countless others. ASA and Abloy are two companies from Sweden and Finland. ASA is, you know, when I think of ASA, I think of their ASA Twin V10 high security cylinder design. Abloy is, I think of them for the same. They have the Abloy cylinder, if you're interested in locksmithing at all, if you were to look into the Abloy cylinder, it is a platform of cylinder construction quite unlike any other type of modern cylinder that you would use in architectural hardware, because it doesn't employ pin tumblers and it doesn't employ springs. It has a system of rotating discs, very much like what you'd have on a safe lock, so that when you're turning the dial, what you're doing when you're turning that dial is you're setting the discs into their proper positions. When you insert the key into an Abloy cylinder and you rotate the key, you move a series of, let's say, 11 discs into their proper position. so that the locking bar or the locking bar can enter the gates of the rotating discs, allowing the cylinder to turn. And Abloy champions their platform because you don't have springs. Springs will fatigue and fail and break down. And according to Abloy, it's a very, very robust design based on there just being a stack of discs that are separated by washers, that when you insert the key, there's no wear on the key as you insert it because there are no springs pushing down tumblers, riding along the cuts of the key. You're not wearing out parts. And when you rotate all 11 of those discs, there's really very little wear that happens on the edge of a key as it pushes a thin disc over. So really fascinating type of key design with many other hallmarks. You can imagine that the design of this key is so unusual by our standards that getting it copied is a foregone conclusion that that's not going to be a straightforward proposition. Anyway, any questions on the 2001 Rectifier by Hes or any other Hes product, please feel free to reach out to us. And thank you.